Python and Pico peeps and wonders of Wi-Fi. I'm Professor John Gallaugher, and in this CircuitPython school lesson, we're going to learn how to access the internet using our Raspberry Pi Pico W. I'm using a Pico W, but this should work with any W series board, including the original. We'll also learn how to get accurate internet time using the NTP service, we'll format time and date, and we'll learn how to schedule jobs to run at given times. Let's connect to big learning. And if you're new here, welcome. At these URLs, you'll find dozens of step-by-step beginner-friendly lessons that I use in the university course that I teach on physical computing, and these include lessons on how to install and use CircuitPython for automatically copying over CircuitPython libraries that your code needs, and how to install and use PyCharm, which I think is the best Python editor for any Python work, including CircuitPython. There are also a bunch of additional projects and maker info on the site. Subscribe, there are new lessons arriving all the time. Now, since we're going to set up Wi-Fi on the Pico W, we need some place to connect to and get data from. Since one of the first things we often want to do when connecting to the internet is to get the time, I'm going to show you how we can get the time using the NTP service. NTP stands for Network Time Protocol, and if you've ever wondered how all of your internet-connected devices synchronize at the same time, NTP is what does that. So first, let's talk how we can set up our Pico to access our local Wi-Fi network. Now, we need to tell your Pico the name of the Wi-Fi network you should use and the password for accessing that network. Now, it's not good practice to put that information in your Python program, so we'll enter it in a separate file CircuitPython uses for this. And that file will be named settings.toml. Now, this file is going to be in your CircuitPy volume, but also be aware that if anybody has access to your Pico, they could potentially access your Wi-Fi network's password. Now, we can put more data in this file, but for now, we'll just save 2 lines. CircuitPy_Wi-Fi_SSID should be set equal to the string that's the exact name of your Wi-Fi network. That's exactly as you would see it appear in your Wi-Fi listings. Same spelling, same cases. If it's not the same in here, you're not going to be able to find your Wi-Fi and you won't be able to connect. And here we also have a second line that says CircuitPy_Wi-Fi_password, which equals the access password for that network. And for my students on campus, the network name that they should use is Boston College, one word, no space between Boston and college, with a capital B and a capital C. So don't use EduRoam, use Boston College. And they should also use an empty string in here for the password. So that's just 2 double quotation marks next to each other with nothing in between. And the reason why my students do that is in an earlier lesson, they should have found their Pico's MAC address and registered that with the campus network using the Helix server. If you're watching this tutorial and you're going to be using your Pico on a campus network like a university, school, or corporation, check with your network personnel, but for home Wi-Fi users, just enter your local Wi-Fi network name and your Wi-Fi password here. So back in PyCharm, I'm going to open up my project pane and look in my CircuitPy volume and open up settings.toml, and you probably don't have anything in here. But if you're one of my students and you do, you can delete whatever's in here. It was just left over from someone who was previously using your board. Then enter in all caps CircuitPy_Wi-Fi_SSID and set that equal to the string that contains your Wi-Fi network name. My students, this is where you enter Boston College, one word with a capital B, capital C. Then below this, we'll say CircuitPy_Wi-Fi_password, setting this equal to the string that's the logon password for your Wi-Fi network. My students, just enter this as an empty string, so double quote followed by double quote. Now let's save this. You might also want to save a backup of this to your CircuitPython school folder, or if you have a folder on your laptop that holds backup files for your board, it's nice to have this file handy so you can just drag it on your board in case you need to reinstall any files. So I'm going to close this now, and I'll open up code.py, and if you've got anything in here, you can delete it. We'll start from scratch, and to get us set up quickly, I'm going to give you some code so that you can access Wi-Fi, and we've got that in our tip sheet. Remember how we access that? bit.ly/CircuitPython, capital C, capital P, -tip-sheet. Then I'll pull up the find command, Command F Mac, Control F Windows, enter y-fi, and this first option isn't it. We'll get back to that one when we work with time, but this second listing under the heading Wi-Fi is just what we want. Now, I give you a reminder about settings.toml, but we've set that file up already, so let's highlight everything from this import statement down through setting the value of this pool variable, copy it, then head back to our code and paste it in, and I'll briefly talk you through what this does. First, we import the libraries we need. If you've been following this series, you're probably using CircUp, and you can import these by typing a single line into the prompt. Otherwise, you need to drag the libraries into your lib folder on your CircuitPy volume. Now, these 2 statements go into your settings.toml file and try to read the values that you set using these strings, CircuitPy Wi-Fi SSID and CircuitPy Wi-Fi password. Now this if statement here will let us know if no value was found for the Wi-Fi name in your settings.toml file. If it fails, the raise statement here causes the code to end. Then we print that we're trying to connect. This is the command to connect to Wi-Fi, which accepts the Wi-Fi name and password, and if this works, Wi-Fi.radio creates the hardware interface to the Wi-Fi chip on your board. That's the piece that physically connects you to the network. It's sort of like building the program's door to the internet. And if this works, we say so. If not, the raise statement here causes the code to end. And finally, we create a pool object. The socket pool lets our program hand out connections to the internet that just about any service we'll need. For example, we're going to access this pool object when we get the time. These specifics really aren't super important. As long as you've got this code to set up your Wi-Fi connection, you should be golden. Then I'll save the code I just edited, open up my terminal. At the prompt, I'm going to use circup to install the libraries I need. So I type in circup space install space -a. Libraries installed. Then I'll get into TO. Save again, and I can see I'm trying to connect to my local Wi-Fi network, and I'm connected. Mission accomplished. Now let's get the time. And I've got code for this on our tip sheet as well. I'll search for time. The headings are mostly alphabetical here, and I need to import Adafruit _NTP and RTC. RTC is the real-time clock, so that's going to create a software clock, and after we set it, it can keep track of time as long as the board's powered on. So we're going to use NTP to get the official internet time, and then we'll create and set our software-based clock, the RTC, using that time. So I'll import these two libraries. And at the end of the code, after I've created the pool object, I'm going to comment that this is where I'm going to get the time. Then I'll head back to the tip sheet, highlight all the code under that import statement through the call to get time, and I'll paste this in at the end of my code. And here's what this code does. We create a real-time clock and call it clock, but this clock doesn't know the time yet. So we call NTP to create an object that we call NTP, and this object can get the time over the internet. We do that with this code here. The NTP class uses the pool that we created earlier, and the TZ offset is the time zone offset. Now it's currently daylight savings time when I'm recording this in Boston. That's 4 hours behind Greenwich Mean Time, so that's what the -4 means. Unfortunately, the offset isn't automatically calculated, so I'm going to need to increase this to -5 when the clocks fall back for standard time. Then in the getTime function, now ntp.datetime actually fetches the current time from the NTP server. We'll put that in a variable called current time. Now current time is a special value that has different components for the different datetime elements. So I'll print out the unformatted current time here so you can see what those elements look like. But this line here uses an F string and string formatters to format the time as hours, minutes, seconds. And the printable date line here uses an F string and string formatters to format the date as month/day/year. Many countries outside the US order their dates differently, so feel free to change that if you want. Then I print out the strings that I created, and finally I set the real-time clock object here with the current date time that we got up here. Now I didn't need to format and print these values. You can reorder this code or even delete the printing code if you want. Then I call getTime. Now I'm going to save the code, but I also need to get into the terminal and run circup install-a. That automatically installs the libraries that this code needs. And if you're not using circup, see the playlist for a lesson on setting it up. Circup is a must-have tool for all CircuitPython programmers. All my students use it. And then I'll get into TO, save and run the code. We're connected to Wi-Fi. We see the datetime struct printed with all of its different components, along with the formatted time and formatted date. Nice! Now for our final trick, we're going to learn how to write code to schedule tasks to run at specific times. And of course, we've got code for this in our tip sheet. So we'll head over to the notes section that's labeled scheduled tasks, and we'll copy this import statement and paste it into our code. We're importing CircuitPython_schedule, but we're going to name this as schedule to shorten the name. Now this library doesn't start with Adafruit, and that's because this is a community library not written by Adafruit, but it's a well-supported library that Adafruit themselves use in their own examples, and Circup will install this for us too. Now let's scroll to the bottom, and then head back to the tip sheet, and we'll grab this line here to schedule our first task. Head back to our code and paste it in, and this says to schedule every day at midnight, do what's between the parentheses. And by listing get time in here, well, that means make the function call to get time every day at midnight. And it's important to remember that when we schedule a function, we don't include parentheses after the function name. So even though we're going to call the get time function, we don't put parens after it. even though we usually do that when we call a function. Now, calling this every night at midnight is a good thing to do. It's going to reset our clock just in case the software clock drifts a bit from the actual internet time. Syncing the clock once a day is a great way to keep time accurate. Now, setting the schedule alone is not enough. Let's head back to our tip sheet, and we're going to go down here and grab the while true code, copy it, and paste it into our code. Oops, and I see some red squigglies under time. That means I haven't imported the time library, so we'll do that now. And what this code does in while true is it checks the schedule, and it will run anything at the time that it's been scheduled. Now, we could check this without slowing down the time in the while true loop, but adding the time sleep of a single second is fine. In fact, you might not even need single second accuracy, so feel free to change that. But we're not checking the internet with schedule run pending. We're just checking the internal job schedule, so this is fine. And now finally, let me show you how we can create our own function and schedule that to run at a specific time. So we'll head back to the tip sheet and we'll grab this chunk of code here that creates a function named job with the def job statement through scheduling this job. Then I'm going to copy this, head back to my code, and I'll paste it in just before I call getTime. And then I'll cut out the schedule command and I'll paste that on top of the line that schedules the getTime function. And this line here calls the function named job, see between the parens, every day at 2025, which is 8:25 p.m. in military time. Now, if I look at my max clock, I can see that it's currently 9:07 p.m. So I'm going to change the schedule time to run my job function at 21:09, which is in less than 2 minutes. That's at 9:09, so I'm going to save this, get into the terminal, run circup install-a to install my schedule library, get into TO, add an insignificant space so that I change my code, save it so that my code runs again, I connect to Wi-Fi, I can see my time is 9:08 p.m., and I'll cut out the wait time from the video. But look up here, when my clock strikes 9:09, which is 21:09, our function runs, and we print out, the scheduled job has ran. Nice! It was indeed time for big learning. We learned to connect to the internet, get time from NTP, create and set the Pico's real-time clock, format time and date for readability, schedule jobs, and run scheduled jobs at preset times and intervals. Those are some pretty advanced skills, Time Lords and Dames of Dates. Let's save this to our CircuitPython school folder as wifi_connect_ntp_and_schedule.py, and feel good about that timely big learning, and be sure to schedule time to make something awesome.